Hello guys, my name is Joennel Almonguera, an electronic engineering student, and today I will explain to you the connection of electronic devices to heat and temperature. So, electronic devices such as computer and power supplies use electricity in order to function. That means it produces heats, and it produces heats, it means that it increases temperature. So, temperature, if you keep it unchecked, it might cause the device to be damaged or might reduce the lifespan of your device, or even worse, it might cause a fire. So in order to reduce those scenarios, we will use some electronic components such as heatsink fan in order to control the temperature of such devices. So heatsink dissipates the heat from electronic devices in the process called conduction. So conduction is one of the mechanism of heat transfer. It transfers the heat from the hotter region to the cooler region. In the case of computer or CPU, the heatsink fan transfer the heat from the processor or CPU to the metal heat spreader of the heatsink. Then it will transfer to the exhaust fan, then the exhaust fan will transfer it to the air or blow it to the air. As you see, I have an active heatsink fan here. I also have a graphics card, and this graphics cards also contain a heatsink fan. So heatsink fan most likely made up of aluminum metal and plastic pan. So it is made up of aluminum metal because aluminum metal has a high thermal conductivity. Although copper is a better or have a higher thermal conductivity than aluminum metal is much more lighter than copper, so it is more reliable to use it in electronic devices such as this.
Hi, I will help you understand what is the application of fluid mechanics into electronics. As you can see, this is the gauge of the car. The oil pressure gauge has a small oil line running from a hole in the engine through the firewall and to the back of the gauge in the dashboard. The pressure is then what moves the gauge. Likewise, the speedometer will have a cable that is connected to the transmission and spins as the car is moving. It is a cable that connects from the fluid, which is the gas, to the engine. When you step on the accelerator pedal, you applied pressure. It will move because there is a pressure.
In today's topic, we are going to learn how fluid mechanics and heat and temperature works on engineering fields. But first, let us define what fluid mechanics and heat and temperature are. First, we have fluid mechanics. Fluid mechanics is a branch of physics that deals with the behavior of fluids. The fluid could be in liquid or gas. Under fluid mechanics is fluid statics and fluid dynamics. Fluid statics is the study of fluid at rest, while fluid dynamics is the study of fluid in motion considering pressure and forces. Next, we have heat and temperature. Let us differentiate the two so we won't be confused. Heat is the degree of hotness and coldness of the body, while temperature is the measure of thermal energy or average heat of the molecule in a substance. The SI unit used for heat is joule, while in temperature is Kelvin. Other unit for heat is calorie, while in temperature is Celsius and Fahrenheit. Heat is measured in calorimeter, while temperature is measured in thermometer. Now that we have already defined what fluid mechanics and heat and temperature are, let us see how they work on engineering fields, especially in electronics and communication devices. Stop muna.